All right, well, why don't we get started? I will introduce briefly our first speaker, Sean Birkel, he's going to talk about climate context for May's 2020 drought. And Sean is, among many other things, the state climatologist for Maine. Sean, the platform is yours.
Great, thank you, Dan. Let's see, bear with me while I get my presentation started. Great, I see some nods, so I assume everyone can see the full screen. Great, well, again, thank you for the introduction, Dan, and good afternoon, everyone. Of course, I want to talk about the 2020 drought, especially because it's now well into April, and there are concerns whether or not the drought from last year could have a signal that persists into this year. And so I thought it'd be helpful to review the sequence of events last year, give some historical context for that drought, an outlook for this season, and then also discuss longer term climate implications. Okay, and of course, talk outline, I pretty much covered that already. And so I'll move on to the next slide, which I want to note that I realize that not everyone may be aware of the role of state climatologists. And there's a state climatologist in every state. And what we do is provide climate services. And that means that we provide data, information, we perform stakeholder outreach, and I work with partners in NOAA, National Weather Service, across the academic community, and also with various people in state government, all to help provide information that can inform policy and decision making. And so as part of this, in addition to what I do as a researcher here at CCI, I'm developing the Maine Climate Office as a resource for climate and weather information. And I've also been working in the past few years with many colleagues in the cooperative extension, and including through the Maine Agriculture and Maine Climate and Ag Network, which is a group of faculty and graduate students here on campus who all have research that relates to climate and agriculture. And we conduct seminars and begin to produce some materials, including farm response to changing weather as one example. And so I just want to notice my relation with that group. And also the next speaker, Rachel, she's in cooperative extension and also within the Climate and Ag Network, and we'll be giving more information on the 2020 drought. I thought it'd be helpful to go over a few definitions. In particular, to note that there are three general categories of drought. There's meteorological drought that relates to precipitation, whether or not there's a deficit or surplus of precipitation. And then an agricultural drought, which links to soil moisture. So the longer there's a meteorological drought, the greater likelihood for soil moisture deficits to develop, and then for there to be impacts to agriculture. And a third type of drought is hydrologic, and that's when runoff from the landscape is reduced, stream flow is reduced, and potentially also groundwater. And that's when the drought can potentially become serious, of course, when groundwater supplies can diminish and wells can run dry. And last year's drought last year we experienced all three types of drought to varying degrees across the state. Now, there are a number of indices for which, in order to identify the severity of a drought. And over here on the left, I list three of the more common indices, the most common being the Standardized Precipitation Index. And that uses only precipitation as an input. So it can be precipitation either at a station or an area average, say across the state of Maine, and represents the number of standard deviations by which the observed precip anomaly for that period departs from the long-term mean. So SPI can be integrated over several months and then compared against the longer-term mean. SPEI is similar to the standardized precipitation index, but it also includes evapotranspiration, which is useful, a useful metric for agriculture. So this includes the movement of water through plants and then the release to the atmosphere through evaporation. And finally, a few other definitions. If you go to the US Drought Monitor, or you may have seen a chart like this on National Weather Service pages, in the US, droughts are ranked in severity from D0 through D4. And you can read through the information here. In last year's drought in Maine, we saw up to D3, so extreme drought conditions. Now, elsewhere in the US, in particular the Southwest, there's been a exceptional drought, some very severe conditions. Also relevant to the US Northeast, and in terms of evaluating the kind of drought that we experience. This region is, in the historical record, it's very common for there to be a short-term, or what's sometimes called a flash drought, that typically lasts from 2 to 6 months. These types of droughts can end very quickly, which is similar to what we saw last year. And depending on what metric we look at for last year's drought, in some ways it does look like a short-term drought. However, there's a question of, will the signal can carry on into this season? And so will it become a long-term drought? And that's still an open question. Well, when I was putting together this talk, I realized it would be important to mention the backdrop of other extremes that occurred last year on a larger scale. There were, of course, the record wildfires in California and other parts of Western US. And you may have seen satellite images such as this from last summer, with enormous area of the US covered in smoke. And this followed a record spring heat wave across parts of the Arctic, in particular across Siberia, record wildfires over parts of Siberia. And as you can see in this US Drought Monitor from late last September, much of the US was in drought. And also I have a couple figures here relating what's been going on over the Arctic. For summer 2020, there was this is based on reanalysis, record high temperatures over the Arctic Ocean and in the lower troposphere. There was strong high pressure blocking on average for last summer. And this figure down here shows you the 850 millibar temperature above the Arctic, and that's what this chart is showing as well. So that would be roughly 3,000 feet above the surface or so. And then over here, we see that there was also the second lowest end of summer melt season sea ice extent in the Arctic, second only to 2012. So there are a lot of interesting and very important climate stories last year. And I see that I also missed record Atlantic hurricane season. That's something that was very, very prominent last year. So with all that said, we had an impactful drought here, but it was kind of in line with some other extreme events going on around the hemisphere. Prevailing weather patterns. These figures here show the overall distribution of pressure from May through September, and shows that there's a strong Aleutian low, and there tended to be storms that were tracking along Canada's boreal forest. And then off the northeastern coast, there was higher than usual pressure, and which was these high pressure conditions tend to be associated with little rainfall, more sunny skies, and so on. Now, in this figure, this shows an accumulation of precipitation from May through September. And you can again see where storms are generally tracking to our north and then also to our south. And these storms that track to the south, part of what happened was that there would be a cold front that would come through. As that wave trough dipped down, the precipitation would be steered off to our south, leaving this gap that under which most of the U.S. Northeast began experiencing drought. Okay, now to step through a quick timeline. The drought began in middle of May. You may recall that in April, there was some late season snowfall. There was also late season snowfall in early May in northern Maine. And this time last year, a drought was not on anyone's mind. It wasn't until in the forecast period leading up to middle of May that there started to be signs of dryness. And by June, there was either abnormal dryness or moderate drought across the state. And as you can see here in these bullet points with a little bit of information, there was also some of the most wildfires were being seen in the state in over 10 years. And that was as early as June that was starting to become apparent. And by July, there's a little bit of relief in Western Maine, but that was short-lived because heading into August, drought intensified, particularly over northern Maine. Agricultural impacts intensified, water resources started to become very restricted, and there was growing concern. And the situation got particularly bad in September, and there was a drought disaster declaration that was made at the federal level that provided emergency assistance to farmers. And then in October, there was a deluge of rain across much of the state that delivered a precipitation surplus. And then from then and then up until the ground froze, there were more beneficial rains that mostly broke the meteorological drought. These three precipitation accumulation charts just show you the various stages of precipitation and dry intervals for Portland, Bangor, and Caribou. And the arrows highlight the intervals in which there were long periods without any rainfall. And I mentioned earlier that Bangor saw a particularly dry interval, as did Caribou and parts of northern Maine and Portland, with up to about 30 days without any rainfall whatsoever. And so again, September was the really standout month, but then significant increases after that. Now, to give you some perspective on past statewide droughts, how the 2020 event ranks, this is a figure from Maine's Climate Future 2020. And this was, of course, produced prior to 2020. I want to note that Brad Lyon of CCI put this figure together. But it shows the 2016 drought, which was, that was impactful a couple years ago. And then also ranks it against the other known historical droughts, including the droughts of record that are the droughts in late 1940s, early 2000s, early 1900s, and in particular in the mid 1960s. That is still the worst drought on record in Maine. And I produced a tentative estimate of where the 2020 drought probably lies on this. And this chart is showing a relationship between the SPI on a 6-month integration versus the precipitation departure from percent annual. So it's relating the duration of a drought to the intensity. Okay, and here's another perspective. This time we can see individual years. Here I'm using the SPEI 5, and that spans May through September. Again, this is the drought index that incorporates evapotranspiration. And you can see that on that measure, May through September, the 2020 event was the worst on record statewide. But how we characterize a drought, it differs on which index we use, and of course, which system we are interested in. So if we were to look at SPEI 12, which would be for a 1-year period, then the 2020 drought does not stand out as much as the early 2000s drought or the mid-1960s drought. I'll note that the shaded areas, those highlight known historical droughts that are discussed in the literature. And then these 3 stars, those are so far the most impactful droughts in the state. So now an outlook for 2021. There's growing concern that, particularly across the Western US, that this is going to be another very dry year, and so the preparations are being made for potential another extreme wildfire season. And in the US Northeast, there's also some growing concern, especially in upstate New York and Vermont, because there's lingering effects from an overall either near normal or slightly below normal precipitation fall over the winter. Plus, it was the 3rd warmest winter on record, at least in Maine, and a very early snowmelt. And so now if we look at the 7-day stream flow totals, and these are charts that are up to date as of yesterday. So far over Maine, stream flow is normal or even above normal, so that's good. The groundwater, it's either normal. In a couple areas, the monitors are showing above normal, but then there's some showing below normal. And so there is concern that drought could reemerge. Unfortunately, in terms of predictive ability, in this region, this time of year, it tends to be only on the forecast scale. And so we can use NOAA guidance, in which forecast models are run for weeks and months into the season to give us some outlook. And for the 3 months outlook, right now they're not showing a whole lot of information about what the precipitation signal might be. However, there is prediction for warmer than normal temperatures, which would tend to dry the ground and could exacerbate the conditions that may set in from this early snowmelt. These 2 figures here show the snow water equivalent depths last year, April 1st, versus this year, April 1st. And so this is highlighting the concern that above normal temperature in the coming weeks, and either normal or perhaps below normal precipitation could see what continuation of last year's drought. Now I see that I've gone for just about 15 minutes, so I'll wrap this up. Just a couple comments on the longer term outlook, Maine's climate. As we report Maine's Climate Future 2020, and also in the, as part of the Maine Climate Council that I and several other people at the Institute are involved in, including Ivan, who's a co-chair of the Scientific and Technical Subcommittee. In that report, we show that the precipitation overall has increased over Maine on an annual basis, but that the distribution of precipitation could potentially change, although the current projected models don't offer definitive guidance in terms of whether or not precipitation will be delivered in more larger events, more largely spaced throughout the year. But we do know the region is getting wetter. That's a function of the warming oceans, more evaporation, and the atmosphere holding more water. That adds potential for heavy precipitation events to develop. Also changes in atmospheric circulation that are occurring largely in relation to rapid warming of the Arctic. And so we know Maine will get wetter. It's uncertain whether or not there will be more of these short-term droughts, but that's a distinct possibility. And note in this panel over here on the left shows the projected temperature warming for the state, which could range anywhere from 2, probably unlikely, and anywhere up to 5 degrees Fahrenheit warmer. So some very significant challenges ahead, and unfortunately, it's being tackled here in Maine with the establishment of the Maine Climate Council and a robust climate adaptation plan. And so with that, and I meant to flip to this slide detailing extreme weather, but I think at this stage, I would like to wrap things up and take any questions that you might have. Thank you.
Thanks, Sean. Does anybody have questions?
Thank you, Sean. I have a couple questions, just clarifying questions. I was a little confused about the difference between SPEI 5 and 12.
Oh,
And I was wondering if you could go over that again, as well, what does USNI stand for?
I'm sorry, what does?
USNI? USNE, you were talking about.
Sorry, the US
I think it's
Northeast.
this area. Oh, okay, great, thank you.
Normally I spell it out first and then put the abbreviation after. I apologize. So it's the US Northeast region. The difference between SPEI 5 and 12 is the number of months for the integration time. So the 5 or the 12, SPE 5 is a 5-month integration as opposed to a 12-month integration. And I chose 5 in that figure because the drought from last year was primarily May through September, a 5-month period. And then the SPEI 12 was shown for an annual signal.
Thank you.
Welcome. Any other questions?
Sean, any idea on how snowfall has changed over that same time period where you showed the increase in temperature and precipitation?
Excellent question. And I have a figure in another presentation with that. Towards the southern half of the state, snowfall has declined. Towards the north, it's increased, and that's since about 1950. And there's an interesting dynamic related to the warming temperatures where there's such a steep temperature gradient across the state from south to north that even in a warm winter, the southern half of Maine can see a lot more rainfall or mixed precipitation, very little accumulation, midwinter melt. But even though it's warmer in the north, the daily high temperatures still tend to be near or below freezing. And so there have been some record snow years, say Millinocket North, even just in the last several, when the southern half of the state saw a lot of rain and very poor snow conditions. And so it's interesting. And so as we proceed into the future, how the snow conditions change across northern Maine will largely depend on how much warming there is and how that affects the daily temperatures.
Do you know if anyone's tracking ice jam flooding across the state and how that's changing?
I'm not aware of, well, my guess is something I can find out. I have colleagues at the USGS and also who work with the state who do track the hydrology. And so there is literature on not just ice out on lakes, but also the timing of snow melt and the timing of maximum flooding following the snow melt, in terms of how the I apologize, I'm getting a little tripped up here, but there very likely is information on that. And if you, I can contact you and I can contact you with further resources from the USGS. There's people on the Maine Climate Council who study hydrology, and within our report, they've included an assessment on how some of the hydrologic metrics have been changing over time.
Thank you.
Okay, are there other questions? All right, hearing none. Let me just quickly get to the right place here. We'll move on to our next talk. Oh, sorry, was somebody wanted to ask something? Nope. All right,
I
our
think it was
next
just
talk.
me turning off my mute. Sorry.
Okay. Our next talk is by Rachel Chapman, who is an assistant professor of sustainable agriculture and who will be talking on effects of the Maine 2020 drought on agricultural producers, a talk that fits very well with what we just heard. Rachel, it's all yours.
All right. Can everyone see the screen? Yes, great. Yes, so I volunteered to go today once I saw Sean's topic because I thought this would make a nice two-part presentation. I am excited to talk with you all today. As Dan mentioned, I'm Rachel Schattman. I'm in the School of Food and Ag, and I'm going to share with you a little summary of a survey that a group of us did targeted towards Maine ag producers. We did the survey this winter after we kind of realized what a dramatic effect the 2020 drought had been having on different sectors in our state. So the survey was a collaboration between the School of Food and Ag, the Maine Department of Ag Conservation and Forestry, UMaine Extension, and MOFGA. And our intention, again, was really to document the kind of impacts that the 2020 drought had on growers in our state, and to start to think about how to address those impacts. So Sean just provided a great deal of context for what I'm going to share with you, so I'm not going to spend any time on background about what drought is or agricultural drought, but rather just dive into telling you about this project. So as I mentioned, the survey was a collaboration. We had additional review on the survey instrument provided by the USDA Natural Resources Conservation Service, or NRCS, as well as the Farm Service Agency, or FSA, since these are two agencies that really do quite a lot on the ground to assist agricultural producers to address the risks and the effects of drought. Because Maine does not maintain a publicly available comprehensive list of farmers in the state, which is pretty common in other states as well, we used a targeted convenience sample to solicit participation in the survey. Specifically, we sent the survey out through a lot of different listservs from the state, from Extension, from MOFGA. And we did this in December 2020 and concluded the survey in January 2021. We use Qualtrics, which many of you are familiar with. It's the online survey platform that UMaine has a subscription for. It's really cool in this application because it allows for branching logic. So if I was a blueberry producer, I didn't have to answer a bunch of questions about potato production, for example. It allows for anonymous submissions, but it also prevents what's called ballot stuffing. So if you try to answer the survey more than once from the same IP address, you get locked out. So that was the way that we were trying to address the fact that we were sending the survey out to such a wide audience and likely some duplicate folks got it. The data is currently being analyzed in R. So we received a total of 246 respondents. 165 of those were complete. We are using partial responses in our analysis for particular questions. The best reported category of respondents was vegetable producers, followed by potato and poultry producers. And respondents came from all over the state, with Aroostook County being the best represented in their sample. The respondents who answered the survey managed anywhere between 1/2 an acre and 10,000 acres, so it's quite a spread. The mean number of acres managed was 484, but the median was 55. So you can see just a few larger producers really skewing that sample. Likewise, the average number of irrigated acres among our respondents was 113 acres, but the median was 1. So just to give you kind of a perspective of the diversity of types of agricultural operations that are included in the survey population. Now, the first thing I wanted to share with you all is the degree to which producers in different ag sectors were affected by the 2020 drought. So if you can look at the chart on the left, you'll see the sectors are listed on the y-axis, and the percent of respondents who reported yield losses of any kind in 2 time frames are kind of the body of the chart. So the first is the yellow circles. these are the number of producers who reported any kind of yield loss in the past 5 years, meaning between 2015 and 2019. And that's the orange end of the dumbbell. As an aside, I'll also tell you that we asked respondents to report on how many years out of the last 5 they experienced loss, and the median number of years was 3 out of 5, which is quite a lot in my opinion. The green end of the dumbbell on the right is 2020. And as you can see, all groups report that some yield loss is typical in the short term, but 2020 really departs from expected conditions, at least in terms of the number of respondents who experience yield loss. So we then asked them if they experienced yield losses in 2020, what was the percentage of their normal production that they did lose, either because of drought or other reasons. And the reason we framed it this way is because there were a lot of other things going on last year. For example, a late frost that damaged blueberry blossoms and tree fruit blossoms. And it's difficult for growers sometimes to parse out exactly what might have driven losses that they experienced when there's lots of different things going on. So our team decided that we needed to give them the opportunity to report these overall estimates, with acknowledging that drought was a big factor. So you can see on the chart on the right that there's a great deal of variability in the sectors when it came to 2020 losses. While producer groups in all sectors reported losses greater than normal last year, low-bush blueberry producers were clearly the hardest hit, both in terms of the percent of producers who experienced loss and the percent of the crop lost. However, we also see notable losses in other sectors as well, including field crops, tree fruit, small fruit, potatoes, vegetables. So the next set of questions that we wanted to answer related to what was driving these losses. We wanted to know how producers were using water specifically and how reliable their water sources were and how they anticipated adapting to drought conditions in the future. So we first asked them to report on how they used water on their farms. And you can see on the slide what sort of uses they did report. Household use is frequently intertwined with farm water use, a point that I'll be coming back to a little bit later. Irrigation and vegetable washing and processing are also frequently cited, as is livestock watering. Less common uses include heat stress reduction, frost protection, as well as a bunch of right-in answers that we got, which included seedling production, grain processing, chemical mixing, hydroponics, cleaning, washing equipment and tractors, kind of a gamut. Respondents were also asked to report on their primary and secondary water sources. The majority of respondents reported that drilled wells served as their primary water source, which is good news for some reasons that I'll show you in a second, followed by ponds with natural recharge. Dug wells, shallow wells kind of dug by hand and lined with tile and things like that, were most commonly cited as secondary sources, followed by ponds with natural recharge and rivers and streams. So now we're going to look at how agricultural producers are dealing with the reliability of their sources. So source failure obviously can have a large impact on a farm business. Of the 44 respondents that answered the survey who reported using a dug well, either as a primary or a secondary source, over half of them reported that their well had run dry at some point in the past, and a few more than that reported that the well ran dry in 2020. Of the 107 respondents who reported using a drilled well, either as primary or secondary, less than a quarter reported that their well had ever run dry, and a minority, only 18%, 19%, reported that the well ran dry in 2020. So this demonstrates the relative resistance of drilled wells to drought conditions compared to dug wells, likely because of the depth, as well as just the efficiency of dug wells being pretty poor. And also because the water table obviously changes as ecological conditions change. And as Sean was mentioning, the type of drought that we experienced last year, depending on where you were in the state, was having kind of hydrogeological manifestations, not just agricultural manifestations. So additionally, as I cited in the previous slide, many users are drawing water from surface bodies for ag purposes. So among respondents who reported using water from ponds and streams or rivers, more than half of these reported last year that the sources had reduced flows that prevented them from using this source. And obviously this has implications not just for agricultural water use, but also for conservation and recreation and ecological functioning. So it's pretty concerning. The majority of the respondents who answered the survey, however, reported that in most years, they typically have enough water to meet their needs. That's what the Northeast is kind of happily situated with, right? Like historically, we've had enough water to farm. However, only a third of folks reported that this was true in 2020, and the majority reported that they did not have sufficient water to meet their farm's needs last year. So we know ag producers use water in all sorts of different ways, and that they use a lot of different sources, and that these sources are reliable during times of drought to different degrees. But what does this mean for producers moving forward? What are their intentions for their future water use? We approached this question from a couple of different angles, but first I wanted to share with you that we asked about their intended water use in several different categories, which you can see up on the slide. In all the categories that we asked about, users indicated that they wanted to increase their water use, which I think is fascinating from a behavioral point of view. Very few respondents indicated that they hoped that they could decrease their water use. And indeed, many people cited that they were interested in investing in equipment or supplies or source development for things like irrigation, livestock watering, milk processing. So by looking at the top bars on each chart, you can see this kind of will to invest. And I want to draw your attention particularly to the household use chart. If you remember a couple of slides ago, I noted that there are quite a few people who use one source of water for both household and farm purposes. Reduced access during periods of drought, therefore, not only affects farm operations, but also basic household functions. And anecdotally, I know a few farmers who are interested in investing in new water sources, either digging shallow or deep wells or tapping rivers for irrigation, specifically so they can divorce that household and farm use. So we also asked what specific investments respondents were interested in making to increase water access on their farm, attending specifically to this question of sufficient supply. Perhaps a bit surprisingly, the majority of the respondents were interested in soil health as an important way to increase access. And this makes sense, right? Because soils that are higher in organic matter and which have better structure both hold on to crop available water during dry periods better, and they also drain better during wet periods. The second most popular investment option was irrigation equipment. But both of these interests rank higher than source development, although I should say there are still many respondents interested in drilling wells and digging ponds. So in my thinking, this points to a real opportunity to expand NRCS and extension programming that supports farmers to develop soil health practices and enhance water efficiency practices as well. We wanted to kind of get into the weeds about what the opportunities and limitations might be around several different practices that farmers could use to increase their water access or water efficiency. So I'm just showing you one of those right now. Many participants indicated their intention to invest in irrigation, as I mentioned, including equipment like pumps or supplies like piping, delivery heads, things like that. Of those who indicated interest, almost 70% reported that they intended to make these investments in the near future. I think people are feeling a pressing need. Respondents were also generally confident that this type of investment would actually work for them. It would change how they were able to use water on their farm, with only a small proportion of respondents indicating a lack of confidence in irrigation's efficacy. Almost 60% reported that they already had the knowledge they needed to make this investment, although they needed more information. About 50% said they needed more information to kind of fine-tune their approach. So this indicates a base level of knowledge about irrigation among farmers, which is interesting because 20 years ago, irrigation in the Northeast was much less common and many fewer people practiced it. There are still opportunities, I think, for professional development and outreach and education with a practice like this. There's a lot of room for growth in the Northeast. We asked similar questions, of course, related to pond installation. and well installation, which I'm not going to show you in the interest of time, but I wanted to point out that perhaps unsurprisingly, interest is high related to all the practices we asked about, but reported financial resources for investing in these resources are low. I mean, what else are people going to say, really? But I think it's notable. So I know this is an ugly slide. I apologize. But what I would like you to notice is that there are kind of a wide array of practices that farms can use to address water access and crop livestock water use. So these are listed on the left, the ones that we asked about. Respondents were asked to report what kind of support they would like, either information or technical assistance or financial assistance for these drought adaptive practices. In this context, when we say information, we're talking about general descriptions of a practice or an improvement, like the reasons behind using the practice or the scientific evidence that it works, whereas technical assistance is more about site-specific guidance on implementation. Respondents indicated that they were interested in receiving additional information about things like water quality assessments, soil moisture monitoring, pond installation and design, and interestingly, navigating surface water pumping regulations, which I think people know are out there, but they're not always quite sure what they are. Survey takers also reported that they wanted specific technical assistance on things like ensuring that their crops got sufficient water. Not many people actually know how to calculate that. Pond installation design and also irrigation systems. And then for financial assistance, there was a stated need for help with deep well installation, ditch work and water redirection, pond installation design, and again, installing and designing irrigation practices, among other things. So I'll just end my talk today by reiterating that drought is definitely something that Maine's agricultural community sees as posing a significant risk to the industry. When the survey respondents were asked about what weather and climate changes pose the greatest risk to their farm operations, respondents reported that drought was definitely the most significant. We could have biased that by the framing of the survey. I totally acknowledge that, but it still was a very clear signal. Changes in water availability also ranked very high for people, as did kind of secondary or tertiary climate effects, such as higher pest, weed, or disease pressures. It's also clear that agriculture in Maine and across the Northeast is really going to be affected by drought in the future, and we could do more to prepare for it. Specifically, respondents indicated that they're interested in receiving additional information, technical assistance, and financial assistance for very specific things, which is kind of a finer grain detail than we've had in the past. We've kind of approached things pretty generally, being like, we're going to help farmers with drought stuff. So this, I think, this survey provides some more detailed direction to how we can support ag in the future. I have a colleague who's fond of saying, if you're a farmer, it's really not about if you can withstand 1 year of any kind of climate impact. It's about the kind of accumulated losses across several years. And I think that's also something that we need to kind of hold in mind when we think about the future of agriculture in the Northeast as the climate continues to change. Now, obviously, we can never protect agriculture from yield loss from things like drought. Like it is an exposed industry. But we can, I think more carefully about how to adapt existing industries like agriculture and other land-based industries to changing conditions that we're likely to see in these coming decades. So this work, I hope, points towards a discrete suite of things that Maine can do to assist farmers while keeping an ever constant eye on ecosystem functioning and conservation at the same time. So with that, I will wrap it up and say thank you for your kind attention.
Thank you, Rachel. Are there questions?
Hi, Dan. I'll ask a quick question.
Please.
Thanks for the presentation, Rachel. I was just curious, with any of the farms that you worked with or surveyed in Maine or in the Northeast, is the practice of existing or kind of constructed ponds or maybe even wetlands for a means of treating agricultural waste of any type, so livestock waste or anything like that, common with any of the farms you've surveyed? And if so, was there any impact on that part of the operation?
That is a really great question. We did not include that in our survey. I do know from my past experience working in Vermont that manure holding ponds are common, but I don't think that they are used kind of dual purpose for, they're used for waste treatment, but they're then not necessarily piped out onto edible crops. They might get sprayed out as a nutrient treatment on hay or maybe field crops. But I haven't heard anything about manure management and the drought specifically. It's a great question, though.
Thanks.
Other questions for Rachel?
Yeah, thank you, Rachel. I was wondering if there's any practice of recycling gray water. Is that something that's being looked at as a solution?
I have heard a little bit about folks in the tree fruit industry kind of exploring different gray water uses in orchards, but I haven't heard it in any other industry, and irrigation in tree fruit is not as common as it is in, say, like vegetable production or even potatoes, I think. So it's kind of like they're the ones that are thinking about it, but then also implementation on the ground is limited. I think the technical piece of it, of like how to do it well, is still a nut that folks are trying to crack.
Okay. Before I do my usual wrap up, I do want to apologize to Nicholas and Lynn. I did not let them know that they were supposed to speak today, so that is on me and not on them. All right. So quick summaries. Sean addressed a very dry topic, the 2020 drought. He had very good reasons for choosing this event. He did not choose it precipitously. Last year, droughts were widespread in this hemisphere from one extreme to another. And one flash that he gave us is that it is still up in the air whether the drought will continue through this year. Given the effects on agriculture, Sean appropriately noted that continuing drought is a growing concern. And this provides a nice pivot to Rachel's talk. We have no drought of research on last year's climate in Maine. Thanks to Sean's talk, Rachel was able to crop out the climate background on the 2020 event and go straight to a discussion of the effects on agriculture. The results of a widely distributed survey revealed yield loss in 2020. There was variability across sectors, but fruit producers were particularly blue. Last year, not as much money grew on trees or on bushes. In terms of water sources, when Rachel drilled deep into her survey, it turned out that those who drilled deep did well. Surprisingly, many responses indicated that farmers want to increase their water use, which isn't exactly going with the flow, although many had plans for how to do this, even though funds have dried up for most of them. Thank you all, and see you in a week.
Dan, I think that might be your best one yet.
It's fantastic. Thank you, everybody.
Thanks all.